So this presentation is a quick overview of cognitive psychology. As you can see from the diagram, it's a really complex area of psychology, including perception, language, thinking and problem solving, human intelligence, which we'll take separately, imagery, memory, which we just talked about, attention, and pattern recognition. So cognition is the thinking, gaining knowledge, and dealing with that knowledge. It includes many, many processes. Some of the simplest ones are categorization, developing prototypes of familiar objects like a cup. When you think of that concept, you come up with all kinds of typical examples. Even conceptual networks, that is, the branching, if you will, of the architecture of the brain. You can make cognitive maps up, which are mental images of spatial arrangements. So if you think about your home, you can walk through your home without getting out of the chair because of cognitive maps. And of course, attention is an important aspect of any cognition and language, which we'll talk about in just a minute, the Stroop effect. There are even some pre-attention processes that are procedures for extracting information automatically. Humans are very good at that, and simultaneously across a large portion of not only the visual field but the auditory field. Attention processes are really important in memory and learning, and of course one good example is the Stroop effect, which I'll show you in just a minute. Problem solving, of course, is the ability to solve problems using or synthesizing information or knowledge from a variety of different areas. So expertise arises from practice and notes increased conceptual ability and complexity, specifically within a particular field. So expertise is a result of practice and does not seem to be affected too much by inheritance. Insight is looking at problems in creative and, if you will, out-of-the-box ways. So some of the characteristics of creativity include finding novel and social applications, novel solutions to social problems. The simplest problem-solving process is trial and error. Try something, it doesn't work, you try something else. Another type of problem-solving is to go from a current state to a future state, and all of the strategies that you use to get to that point become part of that problem-solving process. As I mentioned, the Stroop effect is a pre-attention process. So in the Stroop effect, if you go to the middle column and ask the individual to identify the color of the stimulus, they have no problem. That's the control list. If you go to the congruent list, which is on the left, they identify the color very readily because of the pre-attention process of reading. However, if you ask them to identify the color on the far right, they often have problems, and their time to do this increases because there's inconsistencies between identifying the color. For example, the first one will be green, but at the same time reading, which would be, of course, blue. Problem solving can become very complicated. Anyone that knows an engineer realizes that that's essentially what they do. They do what's called root cause analysis. And so that's how they detected, for example, the tragedy at 3 Mile Island, and of course Chernobyl was through root cause analysis. They want to predict what kinds of errors are going to be made before they happen. So you can use a quasi-scientific method for solving a problem, which would be like doing a research experiment, understanding the problem, generating hypotheses, testing them, and checking the results. Some other strategies include an algorithmic strategy in which you look at every possible solution. The good news is that you will eventually come up with the solution. The bad news is that they can take all kinds of time and money generating all those different solutions. We're more likely to use heuristic strategies, which are common sense ones. So if you have sniffles, a fever, and a sore throat, the heuristic strategy might be that you have a cold. But of course the problem with heuristic strategies is they can be wrong. Sometimes thinking strategies converge and sometimes they diverge. Some of the errors that are common to ineffective problem solving include being overconfident in your solution, jumping to conclusions prematurely, not being able to see things in novel ways called functional fixedness, and of course your mental set. How was your thinking at the time? You can use representative heuristics, which is a tendency to assume that if an item is similar to members of a particular category, it's probably a member of that category, which it may not be. Availability heuristics is a strategy of assuming that the number of memories of an event that are available indicates how common the event actually is. So in other words, you use what's available. Sometimes it's as simple as just reframing the problem. The language, on the other hand, is interesting. It is a series of grammatical and contextual solutions that are effective for people who use that particular language. And it's a way of communicating. Transformational grammar, for example, is a system of converting deep structures to surface structures. So if you're hungry, that's a deep structure, and the transformational grammar is being able to articulate that you're hungry. Now, language and speech are common in all primates, but humans are the only ones that actually use spoken language speech. Bonobo and chimpanzees have language, but they can't articulate speech. Their vocabulary tops out at about 50 words, whereas Coco the gorilla, who passed away a couple years ago, her language included about 1,000 words. So it's a collection of arbitrary symbols that have shared significance for the language using community and that follows certain combinational rules. That's the definition of language. Phonemes are the smallest units of sound. So the sound of a in the word cat is a phoneme. A morpheme is the smallest unit of meaning. So if you look at the word rewrite, if you articulate re, it has the same meaning regardless of its context. Semantics, of course, is the study of the meaning of words and sentences. Attorneys, for example, are really good at semantic arguments. Syntax is a rule that govern how morphemes in language are to be combined in order to form meaningful utterances. So syntax is, for example, how you put a sentence together. It's different in English than it is in Spanish. Pragmatics, of course, is the study of how social context affects the meaning of a linguistic event. So if you've ever told a joke to someone who doesn't speak English, they often don't they don't understand how that's funny because they don't have the pragmatics. And language acquisition theory basically says that we acquire language through imitation, including babbling and different types of speech. If you've ever been around a child who's learning how to talk, they rely heavily on social learning theory to pick up the language. There are different speech centers in the brain. Broca's area in the frontal lobes, the yellow portion, is important in speaking language. The reading area is in front of that. Hearing is in Wernicke's area back, that's the blue area on the brain, and reading is in the parietal lobe. So all these are integrated, so if you think about them as an integrated whole, you can see from Wernicke's area it's what is heard. Reflection happens in the frontal lobes. What is said is in the Broca's area. How it's said is in Broca's area. Silent speech is a connection between Broca's and Wernicke's area, and how you articulate words is input from Broca's area to the vocal cords. The language and speech is very complicated in terms of the neuropsychological phenomenon. So human language acquisition happens because, one, we have the apparatus for speech, and the humans are prepared to speak. There are different stages of language acquisition, which I just real briefly outlined. People that are bilingual use the same areas, and that includes sign language. Being bilingual increases cognitive flexibility. One of the problems for feral children is that they can't hear people, that they have no language because they don't hear models actually speaking, and they often invent their own type of language. So words are seen in context. That's super important. And of course, reading is even more complicated than spoken language. If you track eye movements, people that read quickly often move their eyes quickly. Those are called saccades. And when they actually stop to look at letters, that's called a fixation. Good readers read about 11 letters per fixation. But just because a person reads quickly doesn't mean that they have retention.